So good afternoon, everyone. I welcome all the participants and our eminent guests of the today's session. Welcome to our online STTP on electrical challenges and opportunities. This is day 5 and session 2 of our STTP. And I welcome our guest, eminent guest from my NIT Patna, Dr. Dharmendra Kumar Ji, sir. Professor Dharmendra Kumar Ji was born in Bhagalpur, Bihar, India. He received PhD engineering degree in electrical engineering from Microgrid Institute of Technology, India in 2007. The MTech degree in electrical engineering with specialization in power system engineering from IIT Kharagpur, India in 2010, and the PhD degree in Power and Engineering Systems in System Engineering from Department of Energy Science and Engineering, Indian Institute of Technology, IIT Bombay in 2017. Currently, Sir is serving as an assistant professor in the Department of Electrical Engineering, National Institute of Technology, Patna. He has one and a half year of teaching experience after MTech degree, 6 months of research experience as a research associate at IIT Bombay, and 5.5 months of research experience as a postdoctoral researcher at Arizona State University, US. His current research interest includes stability and control of microgrids, stability aspects of conventional power systems, and solar photovoltaics. Sir has over many publications and good citations of our publications too, and Sir is expert in delivering the expert talks. So thank you so much, sir. Over to you. Please guide the participants. Sir, you are not audible. Hello, sir, can you hear me? Hello. I think there are some technical issues. I request all the participants to be very patient with the technical things. I request all the participants to be patient. There is some technical issues, I guess. So we will be sorting that very soon, and sir is joining again, so be patient. Sir, you are muted. So you can unmute and speak now.
Yeah, I have again logged in. So am I audible now?
Yes, sir. Yes.
Okay, fine. So now again I have to share the screen.
Yes, sir.
It is fine?
No, sir, it was visible for just for a second and then it removed.
Oh, let me share it again. Now?
Yes, sir, it is visible.
Okay, so may I start?
Yes, yes, sir, please continue.
Okay. So good afternoon to everyone. So today this lecture will be an overview of electric vehicle in microgrid. So first of all, I will discuss about the.
The screen has gone.
Oh, again screen has gone. Why this is happening?
No, no, sir.
Wait. So oh, again no. Finding some difficulty to just wait. Okay.
Yes, sir, visible again.
Visible?
Yes, sir.
Okay. Again it gone?
Yes, sir.
Oh. So may I send you the slides so that you can scroll down from there?
Yes, sir. Yes, sir.
Okay, so I will tell when I will tell next slide you can do it. Huh? Just please
Okay.
wait for
Okay.
1 or 2 minutes.
Okay, sir.
This was not expected actually. Just I have sent you the slide.
Sir, you are muted actually. Please unmute yourself. Sir, you are not audible. So can you hear me? Sir, I have shared your slide, and now
Yes.
you're visible. And okay, and
Are you
audible.
getting me?
Yes, sir. Yes, sir. So
Also, may I read it?
yes, sir. You can start reading, and when you will be saying next, I'll be shifting to the next.
Okay. Okay. So please go to next slide.
Okay, sir.
So today's the talk will be basically first of all I will give an overview on what is distributed generation. Okay. After that, the microgrid, its introduction, classification, control, and challenges. Then I will give some brief comparison between the microgrid and the conventional grid. Then electric vehicle scenario in microgrid. So next slide, please. Now, distributed generation. So what is distributed generation? As per definition available in literature, I can tell that distributed generation is an electric power source connected directly to the distribution network or on the customer side of the meter. So depending upon the voltage level, like if we want to install some photovoltaic on our roof, like PV rooftop on our house, then the voltage level will be 220 volt. Fine. And if it is integrated in the distribution system, then it will be the voltage level will be according to the distribution system. Maybe some 11 kV or maybe 4.4 kV or maybe whatever it is. So the distributed generation, depending upon the voltage level, it can be connected to the customer side and to the distribution network. Mainly, if you will see, the power system is distributed in four parts. Like the one is the generating station or power generation. Then it is transmission. Then it is distribution. Then it is the utilization, where customer side, what we can customer side. So after transmission, there is some distribution network. So in the near the distribution network also, we can integrate the distributed generation, and on our rooftop also we can integrate the distributed generation. So depending upon the voltage level. Now come to what is distributed resources. So demand and supply side resources that can be deployed throughout an electrical distribution system as distinguished from the transmission system to meet the energy and reliability needs of the customers served by the system. Distributed resources can be installed on either the customer side or the utility side of the meter. So distributed resources distributed energy resources mainly, it is means if you have the distributed generation and if you have the storage system. So DG plus storage system, this will constitute the distributed energy resources. That is called distributed resources. So please next slide. Now I will tell about the different terminology used for distributed generation across the globe. Somewhere it is called embedded generation. Embedded generation in Anglo-American countries. Somewhere it is called dispersed generation, like in North American countries. And in Europe and some parts of Asia, it is called decentralized generation. So if you will find any term like distributed generation, embedded generation, dispersed generation, decentralized generation, all these terms are same. All these belongs to distributed generation. Now let's come to the rating of the distributed generation. So rating of the when the means debate on this rating of the distribution started means whether a small like 5 kilowatt DG, 10 kilowatt DG, or maybe 100 megawatt DG, 100 megawatt supply distributed generator. This vast range, can we put this vast range in the category of DG? So yes, we can put. So the maximum rating that can be connected to a distribution system depends on the capacity of the distribution system, which is correlated to the voltage level within the distribution system. So depending upon the voltage level, the rating of the distributed generation can be obtained. So as per Electric Power Research Institute, EPRI, if you will see the rating of the distributed generation, EPRI classifies that from a few kilowatts up to 50 megawatt, it will be we can call it distributed generation. From the Gas Research Institute, it tells from 25 kilowatt to 25 megawatt, a huge range. From Preston and Dressler, this is ranging from few kilowatts over 100 of megawatts. And some Cardinal, it's between 500 kilowatt to 1 megawatt. And from Cigarette, some smaller than 50 to 100 megawatt. So there is huge means difference in the rating of the distributed generation. Like if you will see EPRI up to 50 megawatt, but if you will go to Cigarette, it is still less than 50 to 100 megawatt. Cordrel, it is 5 kilowatt to 1 megawatt. So there is some difference in the calling that this will be distributed generation or this will not be distributed generation. So to means overcome this dispute, please go to next slide. Please, yes, thanks. So to overcome this dispute, the based on the size of the distributed generators, following categories are suggested. So means it is divided into micro DG. DG is for distributed generation. Micro DG, small DG, medium DG, and large DG. So for the micro DG, its size will be from 1 kilowatt to 5 kilowatt. Some small DG, its size will be from 5 kilowatt to 5 megawatt. Medium DG, it will be from 5 megawatt to 50 megawatt. And large DG, it will be from 50 megawatt to 300 megawatt. So now we have the a huge range from 1 kilowatt to 300 megawatt. Means the distributed generation 1 kilowatt generator can also be called distributed generation, and 300 megawatt generator can also call be distributed generation. Obviously a 300 megawatt distributed generation will be some parallel generators, generators will be operating in parallel to generate 300 megawatt, and even a single generator can also generate 300 megawatt. So now the first two, micro DG and small DG, these two we can tell that it belongs to customer side, and the medium and large DG you can install this DC to the distribution system. So now, as per this rating of the DG, the dispute is already clear. So from 1 kilowatt to 300 megawatt. So please go to next slide. Now, I will define the microgrid. So what is microgrid? Microgrid, it is defined by the Department of Energy, USA, that a microgrid as a group of interconnected loads and distributed energy resources within clearly defined electrical boundaries that act as a single controllable entity with respect to the grid. So now there are several things here. The first thing is that group of interconnected loads. So means a small area like any college area, any municipality, or any society. If people are staying in like metro cities, then society we call some region like society. So that may be treated as a microgrid. So a group of interconnected loads and distributed energy resources. What are the components of distributed energy resources? The component of distributed energy resources are distributed generation and some storage devices. So these two constitute distributed energy resources. So the group of interconnected loads and distributed energy resources within clearly defined electrical boundaries. So to define a microgrid, we have to define the electrical boundaries. That can be that can control a single controllable entity with respect to the grid. Means if you will see a grid operator, how a grid operator will see that microgrid, a microgrid can be seen as a single entity, and we will see how a microgrid can be connected to the grid. Everything we will see in the next slide. So the definition of microgrid is clear. Simply, we should have some electrical boundaries and interconnected loads and distributed energy resources. Okay, these three things is constitutes a microgrid. A microgrid can connect or disconnect from the grid to enable it to operate in both grid connected or islanded mode, thus preventing power outage. So think if we have a small area and there are small generators in that, maybe so many distributed energy resources, and this constitute a microgrid. This microgrid can be operated in the grid connected mode, or if there is a problem in the grid, maybe some fault occurred, so this microgrid can be isolated, and then this microgrid will work in islanded mode, and in islanded mode there won't be any problem of power outage. In islanded condition also, the microgrid is self-sufficient to feed the load within it. Okay, and if the microgrid is connected to the grid, then if we have excess power, then what we can do? We can sold that power to the utility grid. Excess power can be sold to the utility grid, and the consumers can make money from it. So it's a two-way supply. It's two-way communication, power flow. And size of microgrid may range from housing estate to municipal region. So housing estate means we have like 5 house or 10 house group up to the municipal region. Previously when dispute start, what will be the size of the distributed generation? So that way the some dispute also started, that what will be the size of the microgrid. So microgrid, the size of microgrid will be maybe like a small housing estate, or it will go up to municipal region also. So depending upon the size, the microgrid, like if you will see it's a housing estate, the voltage level will be low, the power level will be low. But in municipal region, the voltage level will be like it will be some municipal region will be some like any distribution system is connected. Municipal region is connected to the distribution system, so the voltage level will be high in that case. Please go to next slide. Microgrid components. So as I told, what are the components of microgrid? So these are the distributed generators, loads, storage. So distributed generators and storage, it will constitute distributed energy resources, and it will have some loads within it, and definitely there will be controller. Controller will control the microgrid, the everything in the microgrid. It will be controlled by the controller. So I will discuss little bit in the next consecutive slide about the controllers and the point of common coupling. What is point of common coupling? Point of common coupling is that from where the microgrid is connected to the utility grid. So utility grid will see a microgrid as a single entity, and it is simply connected to the point of common coupling. So these are major 5 components of the microgrid. Please go to next slide. Now, there are basically 2 operating modes, but I will discuss the 3 operating modes. But basically there are 2 operating modes. One mode is grid connected mode, another mode is islanded mode. But there is when the microgrid will switch its mode from grid connected mode to islanded mode, or from islanded mode to grid connected mode, this is called transition. Okay. So in the grid connected mode, what will be there means the voltage and frequency will be governed by the main grid. Okay, means the voltage, what will be the voltage level of the microgrid? It will be directed, simply dictated by the main grid, because as we know the grid frequency and voltage are constant if it's a step grid. So 1 per unit voltage, and if we are in India, then it's 50 Hz frequency. So it's like that. So the voltage and frequency of the microgrid, it will be governed by the main grid. But in islanded mode, the voltage and frequency will be controlled autonomously. So there are 3 operating modes in the islanded mode, which I will discuss in next slide. And in the transition mode, from grid connected mode to islanded mode and vice versa, there should be power balance, generation and supply balance. So means in this case also, that's why people call this transition mode also as an operating mode. But basically 2 operating modes are there: grid connected mode and islanded mode. Okay, so please next slide. Now, the classification of microgrid. So the microgrid can be classified as AC microgrid, DC microgrid, and hybrid microgrid. So why the microgrid actually, if you will see the literature of the microgrid, then the study started with AC microgrid. People started to build AC microgrid. Then people switched to DC microgrid. DC microgrid means what? Means we have so many DC loads, and we can generate DC power also, like from photovoltaics. And if AC power generator is also there, we can put some rectifier and it can produce DC. So if we have DC load, then why don't we supply the DC power to the DC load? Why the AC power? Then it is through rectifier and it will supply to that load. So to avoid this too many conversion, like from AC to DC, DC to AC, people started to constitute DC microgrid also. Then the picture came, why only AC or why only DC? Definitely we can club it, and this AC and DC microgrid, this can be hybrid microgrid. This can call hybrid microgrid. And a hybrid microgrid constitutes AC microgrid, DC microgrid, and one interconnecting converter, which links from AC side and DC side. It links with AC side to the DC side. And the function of this interconnecting converter is that if we have power deficit in AC side, and if we have surplus power in DC side, so through power that interconnecting converter from DC side to AC side, power can be supplied, and it's vice versa also. Okay, so the hybrid microgrid is now, if you will see the literature, hybrid microgrid is abundant in literature also nowadays. And this the DC microgrid is actually means if you will see the use of DC microgrid, so it is very helpful for this electric vehicle charging technology. So means DC power is there, you just plug in, your vehicle will be charged. There won't be any conversion like from AC to DC or DC to AC kind of thing. So please next slide. Now, so as I discussed about the microgrid control, so grid connected microgrid, voltage and frequency will be governed by conventional grid. But if we will see in the islanded microgrid, there are three types of control. The first is primary control, second is secondary control, and third is tertiary control. What are the difference between this primary, secondary, and tertiary control? The main difference between these is the action. Like primary control acts instantaneously. Secondary control, maybe we can schedule after every 3 hours the secondary control will work, or after maybe every 15 minutes, 1 hour, 2 hours, is up to your will. The secondary control will work, and tertiary control will work only when we have to do the power management at point of common coupling. PCC is point of common coupling. Point of common coupling is what? From where the this microgrid is connected to the main grid. So the what is the role of primary control? The role of primary control is to control the voltage and frequency. What will be the voltage and what will be the frequency? This will be governed by primary control. And there are several kinds of primary controller. Like Malik sir, thoda ये करेंगे lecture दे रहा हूँ सर थोड़ा. The sorry for the disturbance. So the voltage and frequency will be dictated by the primary controller. And basically, if you will see the droop control operation, in that the means when the load increases, the voltage and frequency comes down. So to restore this voltage and frequency, the secondary control acts. This secondary control, what secondary control will do means maybe after maybe after every 15 minutes, the voltage and frequency level of the microgrid will be restored to its nominal value again. Sorry, like if the nominal value of frequency is 50 hertz, fine, and some load came into the in the system and the frequency came down. To feed that load, microgrid will the frequency will be come down and the power will increase, and that much power will be fed to the load as load. So if that voltage and frequency drops, then how it can be restored? So this is the work of secondary control, fine, and that is the tertiary control as the power management at PCC. So please next slide. Now if we will see what are the major challenges of the microgrid. So challenges are load sharing. How generators will share the load. This is a challenge of microgrid. The stability. Since if you will see in the islanded microgrid, it is not connected to the grid. So the inertia of the microgrid is very less as compared to the main grid. So definitely the transient stability problem occurs. Sometimes small signal stability problem also occurs. So these are the major challenges of the microgrid. Some critical load in microgrid also, if it is operating in islanded mode, it is quite possible that some generator may fail, and definitely we will have some critical load. So how that critical load will be fed if we don't have that much supply? So that is also a problem. So this is also a challenge for the microgrid. And transition means from grid connected mode to islanded mode, and from islanded mode to grid connected mode. The power balance, that is the transition mode. And islanding, sometimes unintentional islanding also occurs. So we have to stop that kind of unintentional islanding. So islanding is also a challenge in microgrid. And the major challenge is protection. The protection, how it's a major challenge means, if you will see, if if there is any system which contains 3 generators, and now we have integrated 2 more generators into the system. So now there are 5 generators. So just call point 1, point A. Previously there won't be any generator. There was no any generator. Now one generator is connected to point, and maybe some load change also. So this connection of this generator means what you can do, it alters the fault current level. So random connection, disconnection of generator and load in a islanded microgrid means the protection challenge occurs due to this. The main challenge is that the fault current level. Sometimes it increases, sometimes it decreases. So it will be something like automated, means oh, these many generators are there, these are the locations. So for relay 1, relay 2, relay 3, all these things, this will be the fault current. So this kind of provision should be there. If it will not be there, then this protection is still a challenge. And even in nowadays also, the protection of islanded microgrid is still, the research is still going on this area. Please, next slide. Now, the microgrid and conventional grid, some brief comparison. So, efficiency of conventional grid is poorer in comparison to microgrid. How? In conventional grid, there is only one, it's unidirectional power flow and loss is very high as compared to microgrid. So if loss is high, then definitely efficiency will come down. So the conventional grid efficiency is poorer in comparison to microgrid. Now, large amount of energy in the form of heat is wasted in conventional grid. How? You can say that power is coming from maybe your place is like from the distribution network, your place is like 10 kilometers away or maybe 5 kilometers away, and your place is a highly dense place. So to feed that much load, the current will, that much amount of current will flow for that 5-kilometer line, and definitely the I square R loss will move actually. So large amount of heat in the form of a large amount of energy in the form of heat is wasted in conventional grid. In the case of microgrid, power sources in case of microgrid are small and are located in close proximity to the load. So load is there, we can put a small distributed generator there. So that power source, load, and it can just supply to the load. The generator will supply to the load. So in that case, there won't be I square. There won't be very much I square R loss. So this is the main difference. And the major advantage of microgrid is ability during a utility grid disturbance to isolate itself from the grid with minimum or no disruption to the loads within the microgrid. So the advantage of microgrid, major advantage is that if it is connected to the grid and if there is some problem in the grid, from the point of common coupling, the microgrid can be isolated and the loads within the microgrid can get power from the sources within that microgrid simply. That load and generation will be balanced. So without any disruption or minimum disruption, the power can be fed to that much load. And during peak load period, microgrid prevents utility grid failure by reducing the load on the grid. So just say during peak load period, if microgrid can supply that much, means if it has some reserve and like storage system, and during that period this microgrid will supply that much amount of power. So the load on the utility grid will reduce, and it will reduce the chance of failure of the grid. Please go to next slide, madam. Next slide, madam, please. Microgrid provides significant environmental benefits made possible by use of low or zero emission generator. Like as we know, the photovoltaic cell, this photovoltaic PV cell, there is no any carbon emission since the sunlight is falling on it and electricity is generated. So this kind of this is zero emission generator. This is very much supporting for the environment and very much beneficial. And in case of microgrid, voltage, frequency, and power quality are three main parameters. that must be considered and controlled acceptable standards maintaining the power balance. This is a challenge to maintain voltage, frequency and power quality within limit. In an islanded microgrid, it is challenge. In the when it is connected to the main grid, the voltage and frequency will be dictated by the main grid, and power quality can be maintained. Means some if there is some harmonic load, that much harmonic can be it will take from the grid. So if you will compare the voltage, frequency and power quality issue in microgrid is more in comparison to the when it is islanded mode. When it is operating in islanded mode, these issues are more in comparison to when it is connected to the when it is operating to the grid connected mode. And in case of microgrid, additional device is required to store the electrical energy. Yes, definitely we should have some storage system to store the energy, so during the peak hour it can supply that amount of energy. Next slide, madam. No, actually you moved 2 slides, madam, please. Now we will see electric vehicle. So why this microgrid and distributed generation were necessary to discuss before this electric vehicle? Because we want to know the size of distributed generation, the distributed energy and power resource. DER, sometimes DEPR, people call it DER, distributed energy resources, or sometimes distributed energy and power resources. So a small electric vehicle can act like a distributed energy resource. Maybe 5 vehicles. If you have 5 vehicles, if we have a charging station where the 5 vehicles are, we can not charge more than 5 vehicles. That will also treat as a distributed generation when it will microgrid. When it will take from the power from the microgrid, then it will act as a load. So plug-in vehicle can behave either as load or as a distributed as vehicle to grid. So V2G, this mode, is the term used to describe the system that enables the flow of power between an electric system or grid and electric drive vehicle. So it's a two-way power flow. The electric vehicle, the battery electric vehicle and the plug-in hybrid electric vehicle contain battery to power electric. So as in this conventional car, as gas means like petrol is the fuel. For this, means the battery will supply the power, so that the electric motor will run and the electric vehicle will run actually. The owner of EV can charge the vehicle battery at home, at work, or at parking facilities that contain fast charger. So if the electric vehicle is there, there should be some facility of charging it at home, since maybe some people stay home in the night, some people stay home in daytime and they have some night duties. So definitely we should have some charging facility at home also, so that electric vehicle can charge at home. There should be some charging facility at workplace and charging facility at parking places also. And why this fast charger, we will discuss in next slide. So EV, the electric vehicles, are active energy consumers, often called prosumers, because they both consume and produce electricity. So how it will consume? When it will get charged, it will consume electricity. When it will supply to the grid or microgrid, whatever it is, then it produces electricity. So this is electric vehicle. Please, next slide, madam. Thank you. The basic concept of V2G is that EV provide power to the grid while parked, helping to even out the peak load and stabilize the frequency of the grid. This frequency stabilization problem is major in the case of islanded microgrid. If there will be some peak load, and during that period, definitely the frequency will come down. So at that time, if the electric vehicle can provide power to the microgrid or grid, we can call it grid also, to the microgrid, then definitely it will stabilize the frequency. So this is a major advantage of electric vehicle. The V2G system can provide demand response service to the power grid, enhancing the efficiency and stability of the system during heavy loads. And a V2G capable vehicle offers reactive power support, active power regulation, tracking of variable renewable energy sources, load balancing, and current harmonic filtering. So, what are the characteristics of a capable V2G kind of thing? So, it must offer some reactive power support also, some active power regulation also, tracking of variable renewable energy sources, load balancing, and current harmonic filtering. So, these are the means these facilities should be there for the V2G capable vehicle like that. So, please next slide. So, what are the advantage and disadvantage of electric vehicle? The advantage of electric vehicle is that it produces very low pollution in comparison to gas-based vehicles. Gas-based vehicles means like the petrol or diesel vehicle. So, if you will go to US, if you will type petrol pump, you won't find anything. You have to type gas station. Then you will get, here we can get petrol. So, in literature, you can find the gas instead of petrol or diesel. So, produces very low pollution in comparison to gas-based vehicles. And electricity price is low in comparison to gas price and cheaper. So, electric vehicles, the running cost of the electric vehicle is cheaper. But if you will see the disadvantage, so more expensive than gas-based vehicle. If you will see the complete cost, then making cost, all those things, then it is more expensive than gas. Okay. And the major disadvantage of this electric vehicle is that if you will charge it fully, so as per current scenario, you can go up to 100 to 150 kilometers, not more than that. So after that, again, you have to charge it, and the charging takes hours. So like gas station, we can fill our complete tank within 5 minutes, but that facility is not here. In the charging of this electric vehicle takes hours actually. So these are the advantage and some disadvantage also, like these things. Please go to next slide. Now, if we will see types of charging system. So there are 3 types of charging system. One is conductive charging, one is inductive charging, and one is battery swapping. The battery swapping is best actually. You just take out your battery and take out your discharged battery and just put the fully charged battery. That will be battery swapping actually. So in the conductive charging, power transfers through direct contact. So simple and highly efficient. This can be onboard and offboard method also. Onboard charger, this is slow charging. Offboard charging, this is installed at fixed locations to offer fast charging. So this is the conductive charging. And if you will see, mostly the charging technique is conductive in nature. Go to next slide, please. However, in the inductive charging, this is also known as wireless charging. And how this can be charged actually? Electromagnetic field is used to transfer electricity to an EV battery. And definitely this provides some electrical safety irrespective of weather condition. Even if it is rainy season, you won't find any spark. But this is low efficient and high power loss. That's why this inductive charging is not popularly used. And this battery swapping, what is there in battery swapping? Empty battery can be swapped with a fully charged battery, and peak demand on the grid is reduced. How? You can charge where that battery swapping technology is available. they can charge the battery during off-peak hours. So the peak demand on the grid will be reduced. So battery swapping is also there. So these two kind of charge. Please, next slide. Now, if you will see the charging power levels. So there are three charging power levels. Okay, the level 1 charging. It uses a standard 120 volt AC and the current rating is up to 15 to 20 ampere. Okay, charging equipment is typically installed on the vehicle. And if you want to fully charge your vehicle, then it takes 8 to 16 hours. So a large time spent to charge this electric vehicle. And what is the power level for this level 1 charging? It is between 1.4 to 1.9 kilowatt, depending upon the ampere rating. Okay. And if you will see the level 2 charging, this is preferred method for a battery electric vehicle charger for both private and public facilities. If you will see the private, it's a 240 volt AC, single phase, and the current rating is 40 ampere. But if you will see the public, it will be 400 volt AC and 3 phase and 80 ampere. The current rating is 80 ampere. So what is the power rating of this level 2 charging? This is between 7.7 kilowatt to 25.6 kilowatt. And it takes 4 to 8 hours to charge the battery, fully charge the battery. And the AC to DC conversion takes place on both actually. Okay. So means from AC we have to supply the DC. So definitely the AC to DC conversion is also there. So charging level 2 charging is this. Now please go to next slide. Level 3 charging. This is called fast charging. So people call it to provide an experience similar to gas station to consumers with DC fast charger. The similar experience to gas station means like as we go to the gas station and our vehicle will get full within 5 minutes. Okay. So just to mimic that behavior, but it's not like that. Here also you can charge your battery up to 80% SOC within 10 to 15 minutes. So like that, if you want to fully charge if you have like any bus, not a small car, then definitely it will take 1 hour to get it fully charged. Okay. So the AC to DC conversion offers in an off-board charger. And the 3-phase circuit, and the voltage ranges from 200 volt to 600 volt AC. And the current rating up to 200 ampere. Okay, so this is a fast charger, and the power rating is within this. And so people generally use this DC fast charger to charge their vehicle quickly. Okay, next slide, please. Now, design of microgrid for EV integration. So, what should be our microgrid design for EV integration? So due to mobility, the physical location of EVs are much more unstable compared to traditional DC. This requires that the microgrid controller should be able to. Means, what will be the total number of electric vehicles charging at a time? This we cannot predict. So, to avoid any consequences of this, the microgrid controller, it should be able to learn the type of functionality of the device in the microgrid. Okay. Definitely obtain its energy requirement capability for energy exchange. So it should be, all these facilities should be dynamic. Means like if one electric vehicle came and that vehicle is completely charged and it wants to sell some power. So microgrid should be able quickly to react it. Okay, and come up with a control and exchange, energy exchange scheme. Definitely these should be the facilities of microgrid for the EV integration, so that the rest of the consumers will not affected due to the EV integration, due to the sudden EV integration, due to the random EV integration, we can call it. So use of information such as weather forecast, historical behavior, EV owner calendar schedule, and other relevant data in order to predict the EV connection disconnection from the grid. If these many informations will be there to the microgrid controller, then a microgrid with random EV integration can also run smoothly. So all these information can be used to formulate and solve an optimization problem. Which kind of optimization problem? So the objective function of the objective of the maximizing the usability of EV in providing ancillary services of spinning reserve, voltage regulation, local demand supply, balancing without compromising owner's interest. So like less energy consumption, less disruption. All these things will be should be the objective function. Next slide. So what will be the benefits of anticipating the load of charging EVs and proactive plan? So if our microgrid will anticipate the load change and if it has some proactive plan, then avoid new investments in infrastructure. Okay, so means we know if is in some area, if we will see like within 1 year these many electric vehicles increased, and some of the people are shifting to that area. So we can forecast. Okay, this should be the number of electric vehicles in that area, and if we will incorporate all those things, we will anticipate in advance that this should be the load, then definitely it will avoid some new investment in infrastructure. Our microgrid will be like that. The infrastructure of microgrid will be like that. Optimizing grid assets and extend their useful life. Reduce electricity and transportation cost. Reduce gas consumption. Definitely the gas means like the petrol diesel. Here gas means like the petrol diesel. And reduce CO2 emission and other air pollutants. The improve energy security also. And definitely supply ancillary services including frequency regulation and power factor correction. So means maybe when during the peak load, if the frequency coming down, EV will supply power to the microgrid, and it will help in the frequency regulation, and sometimes it can work in the power factor correction also. So these are the benefits of anticipating the load of charging electric vehicle and its proactive plan. Next slide. Drawback of late response of EV. If our microgrid will not anticipate all these things, and if it has no proactive plan, then what will be the consequences? So the consequences are shorten the life of grid microgrid infrastructure component. Means if the number of vehicle is increasing and we don't have any plan for it, definitely component will burn, and so shorten the life of grid microgrid infrastructure component. Make the grid microgrid less efficient. Losses will be more, so efficiency will come down. It will increase the unit cost of consumers. Random load will do this. Increase grid power emission also. Make the grid microgrid less stable and reliable if we don't have that kind of plan. Okay, so go to the next slide. Thanks. This was some brief. It was a brief introduction of microgrid, distributed generation microgrid, and the electric vehicle, and how a future microgrid, how we can plan a future microgrid incorporating the scenarios of electric vehicle in that.
So thank you so much, sir. Thank you so much for the wonderful session. You have told everything about the microgrid right from the basics, as we have final year scholars and tech students also as the participants. So I hope the participants who are going to do research and in this area, microgrid and electric, and the amalgamation of, interconnection of EV with microgrid will get definitely benefited. And you have, sir, sometimes we face that the presentation is very good, but participants are not able to grasp the whole idea and concept behind that presentation. But your presentation was so simple, and it was very understandable. So I hope all the participants has many takeaways from your session. So thank you so much, sir. I just wanted to share a certificate in the form of gratitude from our institute. Just give me a minute. I will be sharing it with you. So, sir, this is the gratitude from our side, from EX department, SIRT
Madam.
group. Thank you so much, sir, for being here with us.
Thanks.
Thank you. Thank you. So the last session of this STTP online STTP on electric vehicle will be held tomorrow at 1 p.m. So I request all the participants to be there for the last session. Thank you, all the participants, and thank you so much again, sir, for being here with us today. Thank you.
Thanks.